Okay, so the math dealer here, and today we're going to kick out a few more derivatives because you know why? Derivatives rule. Ha ha ha. I know, super fun. So y is equal to 3 to the x. I'm going to follow that pattern. Why? Because my a is 3 and my x, oh, by the way, is x. So if I'm trying to find y prime, I'm going to get 3 to the x, natural log of 3. And then all these other guys are the exact same way, okay? If I have y is equal to the natural log of x, y prime is just 1 over x. So right now you're like, okay, that's nothing exciting. Really, dealer, this is what you're giving me? The kicker always happens when all of a sudden those x's are differentiable functions, right? They're a derivative other than a 1. Fair enough? So for instance, if I have a derivative of a to the u, well, the derivative of that would be a to the u times the natural log of a times du dx. If I have looking for the derivative of e to the u, well, it's e to the u times du dx. Wait for it, yep, natural log, same thing. If I have the derivative of the natural log of u, well, then that is 1 over u du dx. And now my students are always asking me, like, what the heck is this du dx thing? Just remember, we're just taking the derivative of that either power or argument, depending on where you are. If it's the power, find the derivative of the power. Derivative of the power. The natural log, the guy that's u right here, is actually called the argument, and it's a derivative of the argument. So here we go. Let's kick out some of these things. Hopefully, actually, you know what I should have said? Maybe you should pause this, write this down, make a note. Now let's kick out some derivatives. So for example, if I said to you y was equal to, let's say I have not a, silly me, 3x squared, right? And I'm asking you for y prime. You got this, right? I'm going to follow the pattern. The pattern says if I have a to the u, then y prime is a to the u, natural log of a times the derivative of the power. That's what this is. Du dx is merely the derivative of the power. You're not scared, no siree. So here we go, 3 to the x squared. There's a to the u. And then I'm going to do the natural log of a, natural log of 3. And then, of course, I'm going to do the derivative of my u. Derivative of x squared is 2x. So you could really write this as 2x times 3 to the x squared times the natural log of 3. I always think it's funny that I make my parentheses go way up high just because my square's up there. Crack me up sometimes. Anyway, so there you go. There's the derivative of that. Not too shabby, huh? Want to do another one? I know, super exciting. Whoop, whoop. So let's say I have e to the 5x minus 3. And your job is to find y prime. You're not scared, no siree. It's e to the 5x minus 3 times the derivative of 5x minus 3 because we just followed the pattern. E to the u, y prime is e to the u times du dx. Now, some of you might be wondering, well, why don't we write the natural log of e here? Because we did that with the natural log of a up top. Well, remember, the natural log of e, by the way, is 1. So we really don't need to write it, okay? Sound good? All right. I know what you're waiting for. Let's do a natural log. I know. I'm so excited. I can't even stand it. So if I say y is equal to the natural log, and let's say we have 5x squared plus 3. Now, you might be wondering why I don't have absolute values around this. Well, just take note, 5x squared plus 3 can never be negative, so I don't really need the absolute values. Y prime becomes 1 over u times the derivative of the u, of the argument. The argument's derivative is 10x. So my answer ends up being y prime equals 10x over 5x squared plus 3. Fair enough? All right. And what pattern did I find? Maybe I should write that down, right? Y is equal to the natural log of u. Then y prime is 1 over u times du dx. Fair enough? I know. Let's just kick out one more, maybe just one more. If y was equal to e to the sine of 4x, here we go. Y prime becomes e to the sine. Remember, keep it. That's the cool thing about that exponential, that e one. He ain't breaking down. Now I take the derivative of sine, which of course is cosine. Leave the argument alone. If you watched any of my earlier videos, I talk about leaving that argument alone, and then find the derivative of the argument. Fair enough? So I rewrote e to the sine x, just rewrote it. Then I took the derivative of sine and got cosine. Then I took the derivative of 4x and got 4. Fair enough? And there's your answer. All right, this is the Math Dealer signing out. I hope this was helpful.